Hello guys, how are you doing? Very good. Now we're live in here, and now we're gonna check if my audio is properly streaming. Let's see, let's wait until my audio is properly streaming. This is good. It's good and it's streaming. So now what we're gonna do is we're going to share my Firefox in data camp, and here it is. And now I need to go here because we have a new lecture, and this is our third stream of the day, doing applications with pinecone.
Pinecone provides a unique infrastructure for efficiently serving queries. But even with this, querying can become slow if the index contains a lot of vectors. One way to combat this is with metadata filtering. Vectors often have associated metadata stored in the index. This metadata can be strings, numbers, booleans or true-false values, and lists of strings. This metadata can be used to filter the vectors that are searched through during the query, reducing the search space and query latency. To perform metadata filtering, we need to use the filter parameter in the query method. This argument takes a dictionary where each key is the metadata to filter, and their values specify how to filter them. In this case, year is set to 2019, so records with the year metadata of 2019 will be filtered and queried. There's also a second metadata filter, where genre is set to another dictionary where the key is the $eq operator, and the value is what the operation is performed on. $eq is the equality operator, so this filter selects records with a genre equal to documentary. The two filters here show two methods of performing an equality filter, so you might be wondering why the dictionary and operator version is useful. Pinecone provides a number of different operators to perform sophisticated filtering operations. These include not equal to.
Just in case it was the same metadata filters that we were doing with the ChromaDB, which is the local ones that we did in the previous course.
Greater than, less than, greater than or equal to, and others.
So yeah, not equal, equal, greater, greater than, equal, or equal, less than, less than, less than, or equal. In the array, not in the array. Okay.
Let's have a go at filtering for records with year greater than 2019 with the $GT operator. We start with our filter argument and open a dictionary. Next, we use the year key to specify that we want to filter using the year metadata. And finally, we use the $GT operator and 2019 inside another dictionary to filter for later years. We're also going to use the include metadatas argument to include the metadata in the result, so we can verify that the filter worked. There we have it. From the metadata, we can see that the filter was successful in selecting a record from after 2019. You're doing great. Time to master metadata filtering with some exercises.
Got it. So now I'm gonna do, now it's enough from the data camp. Now we're gonna jump into Visual Studio. In the Visual Studio, we're gonna create a new file, which is gonna be filtering queries. And in here, we are going to copy this description, and then in there, what we are gonna do is copy the code from data camp, and there it says you will practice querying the data camp index pinecone. Okay, create to the index and create this vector to retrieve similar vectors. You'll use the metadata filtering to optimize your querying and return the most relevant results. So in this course, we need to get the data camp index, and the query should be similar to the vector. So it should be index.query, and it should be vector it's equal to vector. Then in the filter I should put something like year it's $equal. I forgot that in In Python I need to do like this. Should be 2024 and the it's just this. So I guess I need to just create a random index. So I'll do this and this, and I'll copy this, and I'll put this here. So I have a random vector. I'll pass this vector here, and then I save it, and when I call the first I'm gonna copy this into data camp. I'm gonna copy the key. I'm gonna run it here. Explain the error. The top k is missing, so I should get, in this case, the top k it's equal to 1. So I run the code. It's not QE, it's EQ, which is equal. So in my here it's missing the top k, and here it's EQ. So I should run the code, submit. Here I should run the Python 9, and I should get similar vector. Yeah, just one. All right. Now, now we need to do this the next exercise, which is 10 multiple metadata filter. So in this case, we're gonna do probably something similar, but in this case, we will put several filters. So what we do here is this, but in the filter we will have, it is asking you to do something similar, but in our case we should have, it says the gender metadata is thriller, so I should put here genre it's dollar equals, and this is gonna be thriller. The year is going to be less than, and it's gonna be 2018. And yeah, if I run this code also into here, it's using the key. I'm putting this first into data camp so it can throw me errors here first. Remember that the operators need to have always the dollar sign. So here the correct is dollar here. Okay, I'm gonna run Python, and this is the number 10 multiple metadata filter .py. In that case, it's showing you the matches, so you just need to get the top 1k. So I guess that in order to actually see the vector, I will need to go into the matches, and then I'll need to get into the element 1 and then the ID, and then create the ID. Okay, so let's continue. Okay, now we're going to the section of update and deleting vectors. This is a lecture, so I'm gonna go back to the data camp and I'm gonna show that.
You're doing amazing. Keep it up. In this video, we'll discuss updating and deleting vectors from our index. Updating and deleting vectors ensures that our data remains current. In dynamic environments, data evolves rapidly, and being able to continuously integrate new values and metadata into indexes keeps our applications relevant and accurate. Tidying up our database also helps optimize performance. As our indexes grow, unused or outdated vectors can clutter our storage and slow down query processing. By removing redundant data, we streamline our operations, leading to faster responses and better resource utilization. Finally, updating and deleting vectors is essential for maintaining data integrity. Inaccurate or outdated information can compromise the reliability of our AI system. By proactively managing our vectors, we uphold the integrity of our data and the trustworthiness of our applications. Good data practices aren't only relevant to applications using vector databases, but any application that relies on data. Let's fetch a record from our database. We can see that the first vector value starts -0.0131, and that it has associated metadata. Genre is action, and year is 2023. Let's update this record to update its vector values. First, we call the update method on the index, specifying the ID of the record we wish to update, and a list of new vector values. Similar to when we ingest vectors, we need to ensure that this list is the same length as the index's dimensionality. Fetching the vector again, we can now see that the vector values have been updated. Now to update the metadata. We'll still use the update method, but this time specify the set metadata argument. Specifically, we changed the genre from action to comedy, kept the year information as it is, as we didn't mention it in the update, and added new metadata called rating with a value of 5.
So in both cases, if we want to update, we need to specify always ID, and we should put the set the metadata field in case we want to update the metadata. But in case that we want to update the vector, we need to specify the values.
Data argument. Specifically, we changed the genre from action to comedy, kept the year information as it is, as we didn't mention it in the update, and added new metadata called rating with a value of 5. And there's our updated metadata. Notice also that this didn't update the vector values, only the metadata. Finally, we can update both the values and the metadata of a vector at the same time by combining the two arguments. Now, let's shift our focus to deleting vectors. We can delete vectors by ID using the delete method. We can also delete vectors using a metadata filter. Here, we delete vectors with the genre metadata the delete method. We can also delete vectors using a metadata filter. Here, we delete vectors with the genre metadata equal to action, another reason to store and maintain accurate metadata. Finally, we can delete all records from a namespace using the delete all and namespace arguments. Emptying a namespace also removes the namespace itself, so use delete all with caution. Head on over to the exercises to give these a go.
That's awesome. Okay, so now let's remove the screen. Let's go back to the Visual Studio, and now we're gonna do updating vector values. So we're gonna create a file number 11, update vector values. And now here I'm doing an update of the vector with ID, and I'm gonna put a vector there. So basically what I'm gonna do there is this. So it's something like I'm getting the index, and then in the index I should dot update, and then here the ID should be the one with 7, and then in the vectors it should be the vector. And then if I run this, here's missing the update. Here I update this, and here I fetch. So I update this here, and then I fetch this here. So I should fetch this. Index.fetch ID, and here's gonna be 7, and here's gonna be 0 because it's only 1, but anyway it's gonna return an array, so I need to get a 0. So I guess something like this. I'm gonna run it first in data camp so I can see if it passes properly, and then I'm gonna run it locally. The syntax error. Let's see, what is this? I should be string. I guess here should also be string. So the IDs that I'm passing should be a string. One second, I'm reloading my data camp. The vector, I should pass it as values. Okay, I guess that, okay, I figured out what, and now here I can do this. So here I update the index by the ID 7, and the values I should put the vector that I defined here, and here I fetch that same vector. So let's do Python 11. So now this should get me the, I didn't save. Okay, 1 second. Now it's saved, and now I should run. Now I should print me the fetch vector. So yeah, it's the vector ID 7, the values, and everything. That's good. Let's jump into the next exercise. And now updating vector metadata. So now I'm gonna go here. Update vector metadata, in which in this case I'm gonna update it's asking me to do the same with the 7, but in this case it's asking me to set not the vector, and this is the number 12. This is not a vector, but I need to call now the set meta data, and this is gonna be a dictionary, and in this dictionary is gonna be the genre, which is going to be thriller, and then the year is gonna be 2024, and fetch the vector. Then here I fetch the vector with the same, so it's the same code, but instead of setting the values which will update the vector, now I'm setting the metadata which will update the metadata values. So I'm gonna just first run this into DataCamp just to make sure that everything is running. It's just running properly. Update the metadata. Here's the metadata. So far it's good. Now in DataCamp I'm gonna copy the key. I'm gonna run this code and let's see how it does. Oh, I need to reload the environment in DataCamp. So it work. It said incorrect submission. Did you update? Take a hint. Yeah. Fetch the vector using the fetch. Yeah, I did updated the. Okay, maybe I'll put this wrong with this code. I'm checking because something is failing in my data camp and I don't know what's the thing that is failing there. Because it says that I'm not updating the metadata, but indeed I'm doing it. The year should be a number, so maybe that's why. Fetch vector doesn't have the correct metadata. The ID 7. So it wants me to do it just like this. So basically if I print the vectors I will not see nothing here, so I guess what I need to do is do this and then print just this. So if I run the 12, and then I see the vectors, okay, and then the metadata, okay. Okay, so here I see the metadata updated. Otherwise I wouldn't see it, because if I will go to the vectors, I will just see the vectors, right? Got it. Now deleting vectors. Now I need to do the number 13, but with this I need to be more careful. 13 deleting vectors, and then here I should delete, I should do the same as here, and I should do IDs, and in this case it's asking me to delete the 3, which is 3 and 4. I should put a comma between them, and then retrieve the matrix of the data camp index. So here I need to describe index stats, and here I should have only now 98. So in this case I don't need to do this, so I just need to delete and then print the stats. In data camp I'm gonna copy the key so I can run it. If I run it, yeah, I mean I just run it. I'm just gonna check that in the, now it's 88, 98. If you see now in my public, now you see that when I run it, I deleted, I had 98. So now I'm gonna delete from not from data campus, from here. Now let's delete the 10 and 11, and now it should be 96. So if I run Python, and this is 13, then I should, well, it deleted 98 now because it wasn't updated, but if I show you the pinecone, now it's 96, as you see. So it's good. Total Visual Studio. Okay, now we're good. Now let's continue. So we finished the second chapter. All right, now is just the last chapter, which is gonna be probably more advanced concepts. So now we have been streaming for 30 minutes. I'm gonna take a shower, take a small nap, and then I'm gonna continue studying. All right, so thank you and see you in